Lesson 3, Metamorphic Rocks. Where we left off last time was really focusing on the sedimentary rock cycle. The idea that deposited sediment, so tiny bits of rock that have been weathered away, fall into rivers, oceans, sink to the bottom under gravity. As more and more sedimentary rock or sediment falls on top of them, they get forced down. And this gives us these distinct stages: deposition, sedimentation, as we see these sediments starting to build up, compaction from the pressure pushing down, and eventually, given enough pressure, we get this fermentation taking place, where the minerals leach out of the rock or the particles and cement it together. The formation of metamorphic rocks is largely a continuation of the sedimentary rock cycle. As you remember, we get this build-up of sediment falling to the bottom of the sea, bottom of the riverbed. As the sediment falls, it's deposited, we get a build-up of pressure, and this pressure drives the rock, the sedimentary rock, down. On the inside, so in the inner parts of the earth, you get a massive amount of heat due to radioactive decay, and so this massive amount of heat heats up the rock surrounding it. All around here we heat it up. The pressure also creates a lot of heat, and a lot of force is being put through these rocks. What we see happening to go from a sedimentary rock to a metamorphic rock is a chemical change in the rock structure. So it's not melted and reformed, rather because of the immense heat and the immense pressure, the chemical bonds are realigned, forming these crystals. So you go from a fairly dull sedimentary rock to quite a interesting looking crystal-based metamorphic rock. So it's a chemical change, much in the same way that bread, when you bake bread, you go from a dough, you heat it up, and it goes through a process called Maillard browning, and eventually you get bread. And it's a change in the chemical bonds as opposed to a completely new product. Okay, and this is just a quick diagram of what actually happens. So you get this pressure coming down, pressure from the sides, because a lot of the metamorphic rocks are formed when tectonic plates are moving about. So when they crash into each other, you get this huge pressure building up, and you get this sort of bowing in the rock, getting these very distinctive layers, as you can see on an actual example here. Very distinctive bowed layers. Okay, the final slide is looking at comparison of different temperatures and pressures on the rock type. What you can see is shale up at this end is formed in relatively low pressure and low temperature, around 200 degrees. As you increase the temperature and increase the pressure, you get bigger crystals forming and very distinctive layers. Largely the crystals are formed as a result of the increased temperature, and the layers are formed as a result of the pressure. So as you increase the temperature, you get more crystals forming greater layers and these more distinctive bands, and that's really a sort of defining point of the metamorphic rock.